Okay, I just wanted to give some of you who are coming from other countries and a little geography lesson here. So this is the Santa Barbara region that we're going to be talking about here. Santa Barbara is an important area because of the richness of the marine environment. We have a current coming up this way, California current coming down here, and then there's a gyre that's formed here in the Santa Barbara Channel, which results in upwelling of nutrient-rich sediments, which feeds microorganisms, which then feed the fish, and so on, and kelp beds. And so it's a very rich, productive marine environment here in the Santa Barbara region. Where I'm going to be talking about is Santa Rosa Island here in just a moment. And people have already talked about the coastal migration hypothesis. Mike Waters, I thought, did a good job talking about how there are these two routes of entry that were into the Americas as things warmed up at the end of the Pleistocene. And this coastal route, we know now, opened up probably a little bit, maybe a couple thousand years before this inland route opened up. So it would have allowed people who were living on coastal resources a way of migrating southward and then entering into the West Coast. And this, of course, makes California pretty interesting, and why Santa Barbara is an important place to study the peopling of the Americas because of our geographic location being one of these places that people would have arrived soon after they began migrating south of those glacial ice sheets. And of course, because of this productive marine environment that existed here, it would have been a good place for people to establish a population that would have been then continued on through time. And we have an excellent high-resolution paleoclimate record because of work that Jim Kennett and others have done out here in the Santa Barbara Basin coring. And we have this deep water basin where we have like varved cores, so that you can actually measure year by year accumulation of sediments, go down, study the marine organisms that are proxies for what the sea temperature is doing way back into the Pleistocene on a year by year basis, as well as data on pollen and other things that can be obtained to get an excellent paleoclimate record for the Santa Barbara region that it is hard to get in many other places of the world. Also, our Channel Islands are a wonderful laboratory for research, for archaeological research, for research on the Pleistocene and the Holocene, because there's no biomantle. That is, there's no burrowing animals. Those islands have always been separate from the mainland, so there's no ground squirrels, there's no gophers, there's no earthworms, there's no termites that are churning up the sediments. So we have this wonderful layer cake of sediment accumulation and makes a very high precision archaeological record to study. And it's extensively studied. There are lots of people doing research on the Channel Islands right now and have been in the past. So we have a lot of good data that's accumulated on the course of cultural evolution here in the Santa Barbara region, based on studies on the Channel Islands as well as on the mainland. And from these studies, we have a nearly continuous evidence of a maritime hunter-gatherer society that existed here from the end of the Pleistocene all the way up to historic contact. And it changed through time, but we can study those changes through time and how people continue to use marine resources intensified their use of resources through time. And then we have linguistic and genetic evidence that indicate a distinctiveness for the Chumash population here. Chumash is actually a name of a linguistic family. It's an isolate linguistic family in this part of California that has been here for thousands of years, and the genetic evidence is beginning to show us that it has great antiquity, that the Chumash Indians have been here for many thousands of years in the past. And so if we are going to go back now to the end of the Pleistocene, the sea level, of course, one of the problems of working in coastal California is that sea level has risen. With the melting of the glacial ice sheets, sea level rose and inundated areas that people would have been living along the coast at the end of the Pleistocene. So that's one of the drawbacks here, is many of our sites have been erased from the archaeological record by sea level rise through inundation and through erosion through time. What existed at the end of the Pleistocene, as many of you know, was we had this large mega island off our coast here that was called Santa Rosa. And this is the way that island looked about 12,500 years ago. And so it was all one island when people first arrived in this part of California. And there was a different fauna on that island. There was a pygmy mammoth, as many of you know, and this is the backbone and scapula of the only complete specimen of the pygmy mammoth that's ever been excavated. Most of the bones that are found on the islands are disarticulated, redeposited individual bones, but this is a mammoth that died about 14,500 years ago and was buried by a sand dune and then completely excavated in 1994 by Don Morris and Larry Eggenbrod. And now Larry Eggenbrod, who's done a lot of research on the pygmy mammoths of the Channel Islands and has radiocarbon dated them with the assistance of Tom Stafford doing collagen dates on mammoth bones, has shown that the mammoths come up to about 13,000 years. So we know that mammoths were there when the first people arrived on the island. And I'm going to talk about the Arlington Springs site. It's located here on Santa Rosa Island. Today it's real close to the coast, but back around 13,000 years ago, Arlington Springs was many miles inland from where the coast was at that time. So it's an inland site on that mega island, Santa Rosa. Today, if you go to the mouth of Arlington Canyon, there's an estuary sometimes at the mouth of the canyon, and this is nice sandy beach. These sediments that you see at the side of the canyon, these are partly Pleistocene alluvial deposits sitting on top of an old marine terrace, and they contain mammoth bones here, of the bones of the pygmy mammoth. Phil Orr, he was the curator of anthropology at the Museum of Natural History, and he was doing a long-term research project, both studying the pygmy mammoths and studying the archaeological work or archaeological evidence on the Channel Islands. And Phil Orr, in 1959, discovered the human bone, right there, buried about 37 feet below the existing surface. And there was a human femur sticking out of the sidewall of the canyon. He didn't excavate it, he left it in situ. He then went and got a grant to bring some of the leading archaeologists from around the country. Those of you who are archaeologists in the audience, he had Emil Howry, and he had Jess Jennings, and he had Jimmy Griffin, and some of the leading top people around the country came out there to the island and confirmed that these bones were embedded in sediments, the same formation where mammoth bones had been recovered on the island. And Phil Orr published an article in Science called Arlington Springs Man. He termed his find Arlington Springs Man. Here's a picture of Phil and the Science article. At that time, of course, he didn't want to, there was no possibility of dating the bone and getting an accurate date. So he wrapped up the bone in a plaster jacket, brought it back to our museum, and stored it in a basement location at the museum. In 1987, Don Morris, Channel Islands National Park archaeologist, came to me and he says, he'd just been hired as a park archaeologist a year or two earlier, and he said, I'd really like to get a good date on the Arlington Man. And so we went down into the basement, and Don likes to say he brushed the tarantulas off the back of my vest as we brought it out of the basement. And we opened it up. And so here's you can see here, there are actually two fragments of two femurs. This is the left femur and a fragment of the right femur that were found in situ. Or found, yeah, this is the way they looked in situ. This is Phil Orr's photograph. There was also a ball ahead of the femur, which he sent off to England to be analyzed by Kenneth Oakley. And then here is the way it looked when we opened the plaster jacket in 1987. You can see this femur had degraded quite a bit into little pieces, but this femur was pretty much intact except for missing the head of the femur there. So we began a project. I only thought this would take us a year or two. Here we are 20 years later or so, still studying this site. And here I am excavating in the lab. We wanted to check for DNA, so I wore gloves and masks. And this is Gilbert Unzueta, a Chumash research assistant working with me. We excavated the top part, removed part of the femur. We then sent the samples off to different labs, including Tom Stafford, shown here. And Tom, here he is contemplating the block of earth after we removed the femur. But Tom did radiocarbon dating, and he came back. He was visiting Santa Barbara in 1994 and sat down and said, "John, do you realize you have the oldest dated skeletal remains in North America?" You know, and he showed me the evidence for that. We published an article about it, and we then decided that it would be worthwhile going back and doing additional field work because there were some questions. You know, there was very little collagen left in the bone. It was at the margins of datability, and we wanted to be sure we could date the actual context from which it came to corroborate the age we were getting on the bone. And there, you know, for one thing, the bones were very, you know, the very poor chemistry of the bone. That not much collagen was left. That we wondered about reworking of older sediments. We were wondering about mixing of older and younger carbon. We were uncertain where that block of earth had originally come from. We wanted to relocate that stratum in the field. And so we could only answer this by going back to the Arlington Springs site. You know, what was the exact stratigraphic position from where Phil Orr obtained that original block of earth? Would carbon-14 samples collected in the field corroborate the age that was suggested by the bone collagen dating? And we wanted to look at the sedimentary history of the Arlington Springs site, and we wanted to understand better, gather paleo-environmental data for what the environment was like on Santa Rosa Island at the end of the Pleistocene. So we went back out in 2001 and stepped up the sidewall of Arlington Canyon to do a geological study of the stratum there at the Arlington Springs site. My collaborators in this, my partners in this were Jim West on the left, who's an archaeologist and palynologist, Don Morris in the middle, who was the park archaeologist for Channel Islands National Park, and Tom Stafford on the right, who's a geologist and chemist and radiocarbon dating expert. So this was our team. And we cleared off the sidewall of Arlington Canyon here so we could get a really good look at the stratigraphy. And you can see it's beautiful. There is, because there's no burrowing animals, there was up here, this is a buried shell midden that we radiocarbon dated at 7,800 years. There's another site at the top of the canyon that's dated around 4,000 years ago. And then if you continue down, we get to this ancient valley here, or an edge of a bank that goes down to some kind of creek or something that was existed at that time. And there's this very marked black layer that you see here, which accumulated during the Younger Dryas that you've heard a little bit about today, during that cool period, the Younger Dryas cooling period. And this layer here, actually, though, is the ground about 13,000 years ago. And if we go in closer to look at the bottom of that slope, we come here. And this is the bottom of that black layer. And this then is the other layer beneath it that we were able to determine is where the block of earth came from that had Arlington Man's bones embedded in it. And this particular area, we've outlined it in string here because it's also very interesting. It's full of well, let me back up. A few years ago, we went back and we excavated another pit there. This is again that same layer that was outlined in string in the preceding photograph. And we took some quantitative samples from that layer, being the Arlington Man layer. And it's full of bones of rodent bones and of some bird bones too. And also bones of an extinct shrew. The rodent bones are from a extinct Pleistocene deer mouse that is a lot much larger than the mouse that's found out on the island today. And there's also salamander bones and some other things there. But most of the bones are of this extinct deer mouse, and we think these are decomposed owl pellets that were rolling down that slope and were in the same layer as Arlington Man's bones. And so we've also dated some of these mouse bones, and they showed an age slightly older than the 13,000 year age that we got on Arlington Man's bones. And so we collected some radiocarbon samples. Oh yes, another thing we found in some of our samples that we took at the site from that layer, from the Arlington Man layer, we got no stone tools, unfortunately. This is one of the sites where we're not finding stone tools, at least so far. But we found little tiny chert flakes that are not in that local area. They're found elsewhere. They're coming from sources elsewhere on that large island, that mega island, Santa Rosa. And so these are from the results of tool maintenance activities there at the site. We've had some lithic specialists look at them, and they agree they're resulting from tool sharpening activity. And one of them had a fossil foram in the chert. So we took a picture of it with a scanning electron microscope. So there was human activity going on in the area. It's not just some couple of human bones. There's also some chert flakes present, although scarce. We also took a series, initially we took some radiocarbon dates. These are some of the samples we took back in 2001. This is our initial dating. And they came out very nicely seriated from this being the layer just above where Arlington Man bones came from. And we've got a date that's indicating an age of about 13,200 years. So it appears that Arlington Man's bones are a little bit older than actually we initially thought, that he's a little bit before 13,000 years ago. And we also dated the bottom of the Younger Dryas black layer. It came out around 12,900 years. So we also have done LiDAR scanning of all of our excavations over the years there at Arlington Springs, so everything is precisely located in three-dimensional space, and we've now actually scanned all the way down to the ocean, to the mouth of Arlington Canyon. So we have documented where everything was and where our investigations occurred. But one of the problems with doing a work at a site of this age is that there's a lot of sediment that's accumulated. This Arlington site is right about there. And so you can see all of this alluvial sediment has accumulated on top of the original ground surface. And so we wonder what's down there beneath that ground surface. So we went out with a drill rig, and we did a series of sediment cores there at the Arlington Springs site. And here's Jim West measuring one of the cores as we pulled it out of the ground. We then took them back in the lab. We logged them in and measured and studied and characterized the sediments. and then took samples here, sediment samples, for pollen analysis and radiocarbon dating. Unfortunately, pollen has not preserved most of the pollen seems to have been oxidized here. But this is an example of one of the cores. This one contains that younger Dryas black layer, and right there. And this is the layer we have determined is the Arlington Man layer right there. So what we've done is to take all these samples, and we've gotten some radiocarbon dates on some of the samples. We have another 45 dates that will probably be here in just a few weeks. Tom has processed them all, and with financial support from Eska Willerslev's Center for Geogenetics, we're going to get another 45 radiocarbon dates that will really give a good chronology for all the sediments that have accumulated there on the site. But what we know so far is, well, one of the things is, in order to study these cores, we'd taken pictures of them up at Oregon State University using equipment they have there. And so we wanted to see them be able to compare the different cores with each other. So we created this core poster that you see here. It's about 50 feet long. And so we have the cores lined up here. This Doug Hector, who produced this for us, is shown here. And this is Scott Newhall, who provided the funding for producing this poster. We have mounted it on the, in our lab. It's too long for one, we had to bend it around the corner. So it's half of it's here and half of it's here. And one of the interesting things we've discovered from the radiocarbon dating to date is that this is the top of the cores, so you're going down through time here, that this represents about 10,000 years right here, okay? But this right here represents 1,000 years. So there's a tremendous amount of sediment that's accumulating at this location in this millennium. Arlington Man was right about here, around 13,000 years ago. And then sediment's still accumulating rapidly, but up to about 7,000 or 8,000 years ago when the sea level stabilized. And what we think is happening is that sea level rise is forcing the accumulation of sediments. When sea level falls, the sediments erode down to the level of the sea. When sea level rises, sediments accumulate up to the level of the sea. And so this is a curve here at the bottom from about the end of the last glacial maximum down to the present day, showing for each 1,000 years, how much increase or rise in sea level took place. And you'll see right before the millennium before 13,000 years ago, that's the Bowling-Allerud period, there was the greatest rise in sea level was taking place. And we think this is actually causing this rapid accumulation of sediment at that location. Another thing that is real prominent at this site is this black layer, the younger Dryas black layer. And in the process of doing our work in 2001, we did a traverse of the canyon. We walked all the way down Arlington Canyon looking at the sediments. And Jim West, I wanted to mention a little bit about black layers. Okay, so this black layer is not atypical. It's found all over North America. And this is Vance Haynes from University of Arizona is the first one who recognized this as a phenomenon that begins at the beginning of the younger Dryas and is found all over North America, and that there's never any Pleistocene megafauna above the black layer. All the Pleistocene megafauna is below the black layer, and even in Murray Springs, Arizona, the black layer actually drapes over the bones of a mammoth kill site at that location. And we have the black layer, as I just showed you, out there on Santa Rosa Island. And so Jim West, back in 2001, when we were walking down the canyon, he noticed that there was this dark black deposit. This is further up canyon from Arlington Springs. And there was a log buried in that. And he was kind of frustrated because of not much pollen in the Arlington Springs sediments, so he thought this might be a good location for pollen, so he collected pollen samples, and we radiocarbon dated the log, and it dated to right around the beginning of the Younger Dryas there. And so Jim went back and he did a pollen analysis, and what it turned out is that we had a lot of pine and cypress pollen. This corroborates evidence from Daisy Cave, which is it's actually just on San Miguel Island, and when the two islands were united together, it indicates that there was a pine cypress forest on the island, very different habitat than exists today. And we know from the pollen cores that this disappears after this period. And but the other thing that Jim found was that there were, a few years later, actually, we met Jim Kennett, and Jim Kennett was telling us about carbon spherules, and to be on the lookout for carbon spherules. And so Jim took another sample from that black layer up canyon, did an acid wash of it, and lo and behold, there's these acid-resistant black spherules that showed up in his microscope slides. So we sent this off to Jim Kennett, and ended up, they went back out to Arlington Springs, and it turns out that these carbon spherules are reticulate inside. They have nanodiamonds in them, just like Mike Waters was talking about. So this is a nanodiamond layer right there at the beginning of the Younger Dryas. And they did Jim Kennett and his son Doug did a detailed study here of this location, showing that the very base of that black layer is where we find this nanodiamond layer, as well as finding metallic spherules, glass-like carbon, and other indicators that are argued to be the result of an extraterrestrial impact that hit the northern hemisphere right around this time, around 12,800 years ago. A little bit later on in time, John Erlandson, actually in a location that's just right near Arlington Canyon, has found a site that where he's finding, this is right at the end of the Pleistocene, finding a whole series of projectile points that are these kind of little small barbed points. They call Channel Islands barbed, as well as these crescents. And he first started noticing these on San Miguel Island. Mike Glasso had found some of these in early Holocene sites on Santa Cruz Island. And there's a site really close to Arlington Canyon where you also find these. It's a whole complex that appears to date right from the Pleistocene-Holocene transition, several millennia actually into the Holocene. And John Erlandson argues that this is a paleo maritime culture that looks a lot like, this is from one of John's articles, looks a lot like what you're seeing over here among the people of the Jomon culture at the same time in northern Japan. And these points look almost exactly like what we're finding here in the Channel Islands. And who knows what this means exactly, but one of the ideas is that the first people to colonize coastal California were Paleo-Asiatic peoples living at the margins of Beringia, who worked their way then southward along the coast using watercraft. And of course, just the very fact that Arlington Springs and this other site that John found nearby are on an island indicates that those people had watercraft in order to get out there. The other evidence that we have, I mentioned earlier, is genetic evidence. And one of the rare haplogroups of North America is this, what they call the D4H3A type of mitochondrial DNA. It's found among less than 2% of American Indians. However, it's found some of the most ancient skeletal remains that have been tested for DNA in the West. One of them being this burial from On Your Knees Cave on Prince of Wales Island, and another one more recently that Eska Willerslev was talking about, Mike Waters was talking about, is the Anzac Clovis burial, which also belongs to the D4H3 mitochondrial DNA haplotype. It's also been found one individual from a site in Illinois, and also more recently in some sites on the coast of British Columbia from ancient sites. None of the contemporary populations belong to this group or have lineages that belong to this group. However, it's present among 25% of the surviving lineages among living Chumash Indian descendants today. And it occurs occasionally among people from Northwest Mexico, from samples I've obtained from people who are Mexican-American ancestry. It's found further south in coastal Ecuador among 40% of the Indians of Cayapa Indians, and found all the way down to Tierra del Fuego in prehistoric burials down here. And this is a publication by a few years ago showing the sort of the hotspots of where you find this particular type. And I think it looks, it's coastal. One of the hypotheses is it's an indicator of an ancient coastal migration. These are surviving descendants living in from that very early coastal migrations who are still living in those areas. However, it's much more testing needs to be done before we really can say that's what's going on. But this is a chart from Eska Willerslev and his group's article that was published on the Anzac child burial, showing all of the presence of this type among American Indians. And you can see there's many different haplotypes here. Mostly these are South American types. So here's the Anzac burial here, and this is our Chumash samples fall in here. These are based on complete mitochondrial genomes. And one of the interesting things, I think a few years ago, 2 or 3 years ago, there's an article published about a Jomon cemetery in northern Japan. We don't find D4H3 at all so far in any of the sampling that's been done among living populations in Northeast Asia, but we do find some sister types, and one of them, the majority type of this ancient Jomon cemetery in northern Japan, was D4H2, which is a sister type of DH483. And I think this, again, maybe it's too early to say this, but it's, I think, opening up the possibility that there is a ancient connection between Paleo-Asiatic coastal dwellers of Northeast Asia and the initial coastal migration that peopled the Americas. Yeah. So, further genetic testing is necessary to determine what extent coastal Paleoasiatic populations are linked to California's native peoples. Here's an Ainu man, and this is a portrait of a Chumash man from the early 20th century. Okay. So, to summarize, the Arlington Springs sedimentation record shows very rapid aggregation, correlating with the rise in the largest increase in sea level in the millennium prior to 13,000 years ago. We have indications that watercraft were in use in this population, indicating that watercraft is being used along the Pacific coast around 13,200 years ago. We have pygmy mammoths present on the island at the time humans arrived, and they disappear right about the same time that the Arlington Springs site exists. We have pollen studies that document the presence of a pine cypress forest on the island at the beginning of the Younger Dryas. We have the presence of nanodiamonds, glass-like carbon and carbon spherules in sediments that date to right around 12,800 years ago, which supports for this comet impact hypothesis with that black layer is partly soot that you see at these different sites. And by the beginning of the Holocene, there's a distinctive lithic assemblage that is distinguished by presence of these small barbed projectile points and that resemble similar styles that are being used during the Jamon Paleoasiatic, Paleocoastal Jamon culture of Northeast Asia. And mitochondrial DNA studies, of course, of surviving Chumash lineages suggest an ancient presence in this area and a possible link to early coastal migration. Okay, thank you.